Alright, let's find the worksheet that goes with this video. It is page 22. Get your name, the date, and the period on the top of the page. We're going to start studying for EOCT coordinate algebra right now. Question number 1 at the top of the page. I'm going to read the question once and then we're going to go over it again slowly and read it and underline important information. Number 1. A rectangle has a length of 12 meters and a width of 400 centimeters. What is the perimeter of the rectangle? Okay, this doesn't sound too hard. Let's read it again. A rectangle. Let's underline the word rectangle. And on your paper, where it says I1 or it says sketch a rectangle and label it correctly. So let's do that. Let's draw a rectangle. Now, as we read along the question, it says it has a length. Length is usually the longer side. It has a length of 12 meters. You want to put that on the longest side of your rectangle. I placed it on the bottom. You could put it on the top. It then goes on to say that it has a width of 400 centimeters. Width is always the shorter side. So let's place that along the side there. Alright, now the directions say, because those are just givens, but the directions say what is the perimeter of the rectangle. Alright, now what is perimeter? Perimeter is the distance around the rectangle. It's not the blue inside, that's area. We want the perimeter, it's the distance around. Now, are the units given in the problem the same? Okay, that's one of our standards, being able to switch back and forth from units. You'll notice it says 400 for the short side and 12 for the long side. That doesn't make sense until you realize that the 400 is centimeters and the 12 is meters. And yes, it does, because centimeters are small and meters are large. Okay, now how can we change them so they're all the same? Well, one of the things you want to do when you're working a problem like this is you want to look at your answers. Notice that your answers are all given in centimeters, so we're going to want to change the meters. Meters are bigger than centimeters. In fact, there are 100 centimeters in a meter. So we're going to take our 12 meters, and because there's 100 centimeters in each meter, we're going to multiply it by 100. Okay, you have a place to show how you change it. That's question number 2 on your paper. Write this down, pick up your calculator. What do you get? Did you get 1200 or 1200? You should have. Now, we want the perimeter. This is a rectangle. It has 4 sides. We want the distance around it. Now be careful, because what you're going to do is you need 4 different things to add together. Notice that I have 1200 plus 400 plus 1200 plus 400. The rectangle has 4 sides. Put that in your calculator. Also, guys, write this equation down on your paper. You must show all your work. What you get? Question number 5 says, circle the correct answer. It should be there if you've done it correctly. Okay, we're still on the front. We're at the bottom now. And it says your turn number 1. I will read the question to you. However, you will have to work it yourself. I'll give you a few little clues. Alright, your turn number 1. A rectangle has a width of 100 centimeters and a length of 50 millimeters. What is the perimeter of the rectangle? Now when you go to do this, it's going to be just like number 1 that I helped you with, and you'll notice it's set up and you have to show all your work. Again, remember that you want to change your units into the units used in the answer. You probably want to pause the video and do this work. Make sure you answer all the questions 1, 2, 3, and 4. Okay? Get to work. We're now on the back, but I want to talk about the front for a minute. Notice on the front, didn't we work more with units? We just found the perimeter of rectangles. That's not ninth grade EOCT question. But the fact that we had the rectangle, one side was in centimeters, the other one was in millimeters, or one side was in meters and the other side was in centimeters, we had to deal with units. We're going to do the same thing on the back, in that we're going to be working with units again. Okay, so let's get to the back here. Let's read question number 2. Again, I will read it through quickly and then we'll go through it slowly. I will help you with problem number 2, then you will do your turn on your own. So pay attention. Also, look at your worksheet right now and notice that there is a box that I have provided for you that says fill in the current measurements into the correct formula. Okay, so you're going to be doing your work. That's where I want you to show your work for your teacher. Okay, all right. Question number 2 on the back. The tension caused by a wave moving along a string is found using the formula T equals m times v squared all over L. If m is the mass of the string in grams, and L is the length of the string in centimeters, and v is the velocity of the wave in centimeters per second, what is the unit of tension of the string? Now, I am almost positive none of you have seen this formula before. It's a formula from physics, okay? So when you take physics, you will be using this formula. But the whole thing is, you'll notice they gave us no numbers, did they? We're working in units and only units. So let's start out by writing down T equals, and let's put down our vinculum. Put that in the box and leave room because we're going to have to do a little bit more work than just write it down. Okay? I'm going to read this to you again, and I'm going to start on the line that says if m is the mass of the string in grams. We're talking about m. M is in the top of your fraction, in the numerator of your fraction. Okay, so what we want to do is we want to put grams in there because we measure mass in grams. Alright, let's look at L now. L is the length of the string in centimeters. Okay, L is measured in centimeters is what they're saying. L is at the bottom. We're not doing anything fancy to L, so we just write down centimeters. Let's talk about V. V is the velocity. Another way of thinking about this, it's your rate, it's your speed, it's your velocity, okay, of the wave in centimeters per second. This is like miles per hour. Now, when you have the word per, that means you have a fraction. The fraction is going to have to go into the top, isn't it? Isn't that where the V is? It's in the numerator. And not only is it going to be in the numerator, we are going to be squaring it. Oh gosh. All right, now, centimeters per second is a fraction that goes onto the top of our fraction. Don't forget to square it. What do you think that's going to look like? What about that? Okay. That's what you should have written. All right, I'm looking at this and I'm going, ooh, I need to simplify this. But how am I going to do it? Well, I'm going to do it by changing everything into a fraction. Okay? Now this is what I'm talking about. So this is why we need some extra room. Right below what you just wrote, let's come in and say t equals. I'm going to take grams and I'm going to turn grams into a fraction. So in other words, because it's in the numerator, the 1 goes in the denominators, and I have that. The centimeters per second is already a fraction, and I'm squaring it. Now that means I'm squaring the whole fraction. That means the centimeters are squared and the seconds are squared, and so that's going to look like that. The centimeters that are in the denominator need to stay in the denominator. To keep it in the denominator, I put a 1 on top. Now, I don't know about you, but this looks a lot easier for me to work on. Now, I want you also to look at the answers. Okay? I'm going to come in here. I'm going to start on the left-hand side, and it says grams. Is there any other place where it says grams in that fraction? Are grams going to be canceled out? No, they're not. So I'm going to go up to question A, or answer A, excuse me. Answer A, our answer has to have grams in it. So I'm going to do some eliminating. In answer A is the word grams in it. If grams is not in it, scratch it out. Let's look at B. If B doesn't have the word grams in it, scratch it out. Let's look at C. Does C have the word grams in it? If it doesn't have grams, scratch it out, because it can't be the answer. Look at D. Does D have the words grams in it? We decided the answer must have grams in it. If D does not have grams in it, scratch it out. Now notice you should have been able to scratch out 1 or 2 of the answers. Okay, now that gets us down to fewer to work with. All right, let's come in here. I have in the green, I have centimeters on top and they're squared. But if you look over to the right, I also have centimeters in blue. Now notice I have centimeters in the denominators and 2 centimeters up in the top in the numerator. I can actually scratch one of those out because they cancel each other out, don't they? I'm not going to have centimeters in the denominators. I'm only going to have 1 centimeter in the numerator. Okay. Now you might want to go back and look at your answers that you got up there. Which one has centimeters in the top and not in the bottom? Also look back at the green. That fraction, it has seconds squared in the denominator. So we're going to have seconds squared in the denominator. And also notice that all your answers have the word per in it. Remember the words before per are on the top. The words after per are on the bottom. Numerator and denominator. Okay, I'm going to let you figure that out and finish it up and circle your answer on that page at the top. All right, your turn, number 2. It's dealing with Newton's law of gravity. Okay, and I gave you kind of a little picture here on the right. That's a diagram of what we're doing, and you have a picture of Sir Isaac Newton at the bottom. He was one smart dude. Okay, he has lots of laws, but this is Newton's law of gravity. Okay, here's your question. Have you ever wondered why the moon revolves around the earth? Well, so did Sir Isaac Newton, and he came up with a formula to find the attraction force between the two objects called Newton's law of gravity. And you'll notice in the red we have Newton's law of gravity. It is F, the force of attraction between the two objects, equals G, okay, capital G by the way. In the top of the fraction, in the numerator, it's M1, M2. You might want to look at the diagram up at the top of the page. Notice the blue ball is M1 and the green ball is M2. And then we have R squared. Notice that's the distance between the two spheres. Okay? Now, you're going to do this on your own, but I'm going to read it to you. If G is the acceleration due to gravity, is equal to newtons times meters squared, both divided by kilograms squared. Now, let me tell you about newtons. Newtons is kind of like volts. It's a way of measuring things that they use in physics class. Okay, it's not measuring how far it is from there. It's a measurement of force. Okay, so that's kind of new for you. So keep that in mind. Don't let it throw you. All right. Remember, it's newtons times meters squared, both of them divided by kilograms squared. All right, and you do have a box on this one to write this in. Then I have M1 is the mass of the first object measured in kilograms. M2 is the mass of the second object measured in kilograms. Think about where they're going to go in your equation. R is the distance between the two objects measured in meters. What we're going to want to find out is what is the unit of attraction of the force F. Okay, you're on your own. When you are done, you need to turn this into your teacher. Oh, let me just read the answers to you. A is newtons. B is kilograms squared. C is meters squared. And D is meters squared over kilograms squared. It's not that hard. Look at it, work it out. And again, when you're done, you turn it into your teacher. Bye.